Hello everybody, so today we are going to finish up, or this week we're going to finish talking about section 6.4, which was dealing with our z-score tables. So a quick review of what we did. We first learned about the z-score 2 weeks ago. We got our formula for it here, right? That's when we took the data value, subtracted our mean, divided it by the standard deviation. What we got was a z-score, which tells us how many standard deviations away from the mean that data point lies. And what we could do with those z-scores, with those increasing or decreasing amounts of standard deviations away, is we could find the area underneath the curve corresponding to those z-scores. Those are important because it can represent the chance of something happening. It really depends on the data we're taking a look at. Hopefully it'll make a little more sense once you go and do a few of the questions. And then what we did in 6.4, so all I'm trying to say is here, these are whole number z-scores, so +2, +1, -3, whole numbers. And we get these percentages that we see here. Obviously, we can be any z-score amount away. We don't have to be whole number amounts, right? We can be 1.5, we can be 1.1, -2.7 over there, right? And what we'll need is we'll need specific and accurate percentages for any number of the z-score. That's when our z-score table came in, right? So if you remember these guys here, reading this table, all of these decimals here represent the area underneath the curve for any given z-score, right? So again, there's a table in the last page of your workbook that looks exactly like this. If you don't have your workbook, you can just go to z-table.com. That's this website I'm using, and it has a list of all the z-scores that you can use. So remember, up here we have the negative values, and over here we have the positive values. Okay, so what we did, sort of introduced that, how to read it, how to use it, using our z-score formula to find those z-scores to do it. And let me see, we did a few simple examples. So if you remember, the most important thing using this z-score table is it's always the area to the left. Okay, you have your z-score here for the data point we're talking about. So right here is the data point. You can calculate the z-score of that data point using the z-score formula, and then you use the z-score table to come up with the area to the left. Always to the left. Okay. So we did a few basic examples with that idea last week. This week we're going to go in and we're going to take a look at a few of the trickier questions I could ask you to do. Okay, so let's start with this one here. Okay, on the normal curve below, shade the region where, so what this means is the area is going to be between -1.75 and -1.02, and state what percentage of the data lies between those two z-scores. Okay, well we can make a quick sketch of that. So we can say that -1.02. So remember the z-score of the middle of the mean, that's 0. Okay, so if we were going to have a -1.02, it's going to have to be somewhere over here, for example, and then -1.75, of course, is going to be slightly less. Again, this is just a rough sketch. So there is z equals 1.02, and here is z equals -1.75. And we want to know the area between those 2 points. So we're interested in this region right there. Okay. Question mark for that point, or for that area. Okay, so a few differences between this question and the question we saw previously. So first of all, we have two z-scores here. Okay. And second of all, we're no longer worried about all the data to the left. Okay, so all this data here, we don't care about it at all. And that presents a bit of a problem, right? Because when we use our z-score tables, it always gives us the area to the left. So what do we do? Okay, so all we have to do is we need to break this down into two pieces. Okay, so if we take a look at this z-score here, so I'll call this z-score 1, I'll call this one z-score 2. So if we take a look in the table for z-score 1, it's going to give us everything here and to the left. All right, so let's go take a look. So, oops, that should be negative 1.02. Okay, so this will be from table. For z-score 1, and notice how I'm not writing equals, I'm just going to be writing down the percentage of the area. So z1 is negative 1.02, so we'll go and write z-score here. So the first two numbers are negative 1.0, so that's going to be this guy right there, right? And the third number is 2, which is going to be this guy right there. Okay, so I'm going to go down. So negative 1.02 is right here. 0.1539. Oops. And of course, that's the same thing as 15.39%. Make that 5 look a little better. There you go. Okay. Okay. So that means everything from here to the left makes up 15.39% of the data. So to be clear, it includes this. Okay. So that's not the answer to our question, but it's the first step. So why do we care about that amount? Well, what we can do now is if we go and look up the value from the z-score table for z2, that's going to give us strictly this amount. So if we take, whoops, draw that in again. So if we take this z-score value here, which gives us all of this, and from that, subtract the z-score area for this part, what we're going to have left is just the green portion. Okay, so we're going to take the z-score of 1, subtract from it the z-score 2, and what we'll get is just that area. Okay, so we're going to look for negative 1.75. So the first two numbers is negative 1.7. That's right here. Third number is 5. That's right here. So I'm going to go down, boom, right there. So it's going to be 0.0401. Which of course is 4.01%. Okay, so between negative 1.75 to negative 1.02 is going to be 15.39% minus 4.01%, which is going to give us 11.38% of the data is going to be between those two numbers. Okay, so just to be clear, we took all this data, subtracted from it this data, so all we have left is just this data. Okay? All right. Sometimes you'll see some questions asked like this. So the z-score tables can also tell us the probability of picking any random data point and getting it into that range. So probability typically is listed as P of something in brackets, okay? So for example here, this is saying what's the probability of landing in the area between negative 1.83 and 2.65, referring to the z-scores, of course. Okay, so it's asking you the exact same thing. The percentage of data underneath the curve is exactly the same thing as the probability for finding any random data point in that range. Okay, it's the exact same thing. So essentially what it's asking us here, so this is a negative number, so a negative number is going to be over here somewhere. Okay, so that's going to be, call this Z1, it's negative 1.83, and positive 2.65, let's say that one's over here. Call this one Z2, that's 2.65. So this time, and notice how I drew this one a little farther out, because if this one's 1.83, negative 1.83, this one's going to be farther out because of course the curve is symmetrical. So now we're interested in this area here. Did you guys see the Tiger King documentary? That thing was nuts, dude. Would recommend. Anybody who hasn't seen Tiger King, go watch Tiger King. It's really good. Okay, so now we're looking for this area. And, well, if you take a look, it's basically asking the exact same thing as the previous question. So we're going to take the area for 2.65, which is going to be all the data from here to the left, and subtracting from it the area for negative 1.83, which is this, and what we're going to have left over is just the area we're interested in, right? Okay, so from our table again. So Z1, negative 1.83. So negative 1.8, first two numbers. 3 is our third number. So that one's going to be 0.0336, which is just 3.36%. Z2, 2.65, so that's positive. Okay, so we got to make sure we're looking at our positive z-score table. And down here. So 2.6 is there. 0.5 is there. So we're going to come down. 2.6 right there. So that's going to be 99.6%. 60%. All right, so what we're going to do, again, take the larger amount, subtract the smaller amount, and what we're going to be left with is the amount between those two, which is in this case going to be 96.24%. And that's the probability of getting a data point in this area. Okay. All right, let's do a few trickier ones. We can go the other way, right? So here, I'm giving you the percentage of the data, right? And now I'm asking you for the z-score. Well, now that's just going backwards on our table, right? So right away we can see that this is 0, right? This is z equals 0. This is to the left, this z-score. So we know this is a negative z-score. So what we're going to do is we're going to go into the negative z-score table, and we need to find one that says 17.62%. Remember, they're given as decimals, so we're going to be looking for 0.1762. So let's go take a look. 0.1762. Where is that going to be? Right there. There is 0.1762, right? So we'll go take a look. That is going to correspond to negative 0.93. That's it. If 17.62% of the data lies to the left of that z-score, we know that z-score has to be negative 0.93. We know that whatever data point that is going to be negative 0.93 standard deviations to the left of the mean. Okay, we're just going backwards now. That's it. What about this one? What do you notice about this one? What's different? What's different between all these ones that we've done previously and this one? Look at the side that's shaded. This one's shaded to the right, not to the left. Okay? And remember, the z-score tables only deal with questions that are shaded on the left side. So we have to do something clever here. So we know all of the data, everything is 100%, right? If we shaded everything on the under the curve, that would be 100%. If we want this area, all we have to do is subtract this area from it. If we take 100%, subtract from it this, all we're going to be left with is this, right? So what's that going to be? 85.08%, I think. Make sure, just double check that before I continue. Yeah, that's correct. All right, so as a decimal, of course, that's going to be 0.8508. And we know that this z-score is going to be a positive z-score because, well, that's our z-score of 0. This z-score is to the right, so we know it's going to be positive. So we're going to have to go to our positive section there. So we're going to look for 0.8508. There's 0.8508. Right there. 0.8508. So that's going to be 1.04, right? 1.04. Yeah, so now we know if we take a z-score that has 14.92% of the data to the right of it, that z-score must be 1.04. It has to be 1.04 standard deviations away from the mean to the right. To the right because it is positive. Let's do this one. Determine the indicated z-score on the following curve below. All right, so we got here. Here we have 0, and here we have the z-score we're looking for. What do we do? Well, we want to be looking entirely to the left. We want to be looking at all this shaded part plus this shaded part. But we're only given this shaded part. So we need to know what this is so we can add it to that so we can find that. Well, we know that this z equals 0, this is the mean, the median, and the mode. That cuts the curve exactly in half. It's exactly in the middle. So we know that this is 50%. This side is exactly 50%. As a decimal, that's 0.5. Okay, so together, that's going to be 0.7580. Right? That's 0.5 plus 0.2580. So now we got to go and find the z-score table entry that has 0.7580. Right there. Okay, so it's going to be positive 0.70. 0.7. So we know that's 0.7 standard deviations away from the mean. That's it. Okay, so I hope you guys understand what I mean when I say, some of these questions can be a little tricky. You have to kind of be clever with them. Okay, sure, let's do this last one. We've been here for a while today already, but we can do this one real quick. All right, this time we're being asked to find two different z-scores. We're being asked to find z1, we're being asked to find z2. Okay, so it looks like everything here is to the left of the mean, which of course, for the 80th time, this is going to be the z-score of 0. So everything to the left here total, from here to here, has to be 50%. Has to be, because the mean cuts the data exactly in half when it's standard, when it's evenly distributed or normally distributed. So if we know this one is 0.1292, we know this one's 0.2145, we know that this has to be whatever is going to allow us to add up to 50%, right? So what I'm saying is 0.1292 plus 0.2145 plus our unknown area here, this is x, what I'm calling x, must equal 0.5. Okay. So what I'll do is I'll do 0.1292 plus 0.2145. That gives me 0.3437, which means x has to equal 0.1563. Okay, so we know that this area is equal to that. Why do we care? Well, now we can find Z1 straight up, right? Because that's the area all to the left of negative, or that to the left of 0.1563, right? So we're going to have to go to the negative values and try to find 0.1563. 0.15. 63 is nowhere to be found. So sometimes you're going to have to take things that are as close as you can. The closest one is going to be this guy, 0.1562. We're off by 0.0001, but that's okay. That's about as close as we can get. Okay, so that's going to be negative 1.01. What's happening? And Z2, well, Z2 is going to be this area plus this area, right? So that's going to be 0.2145 plus 0. Add those together. 0.3708. So we got to go take a look at that for the negative values. 0.3708. So that's going to be, that's about as close as we're going to get there. So that's going to be negative 0.33. All right, so those are our two z-scores. All right, so what you guys can do now is you can go in and you can finish up everything else from section 6.4. Should be good to go. So page 277, questions 1 to 7. So go ahead and get started. Make sure you post or message me in Discord if you have any questions. All right. Stay safe out there, everybody. See you next week. Bye.